You know, there's that incredibly famous saying, there's only one thing guaranteed in life, and that's death. And honestly, that would be entirely true if you just completely ignored all the magnificent, mind-bending horrors of the deep ocean. Welcome to This Explainer. Today, we're plunging into the pitch-black abyss to uncover a mystery that totally defies the laws of nature. Because down in the crushing, freezing depths, there are a select few creatures that have somehow managed to cheat the universal rule of death. We're talking about the deep-sea immortals.
I mean, everything is supposed to die, right? Mammals, insects, trees, us. So how are these animals actually pulling this off? Well, it brings us to the central question we're going to explore today. What exactly do you have to sacrifice to live forever? Because, as we're about to find out, true biological immortality, yeah, it absolutely does not come for free.
Now, to understand how truly insane these deep-sea lifespans are, we first have to look at our limits up here on the surface. When we think of a long life, we usually picture, say, a giant land tortoise, right? Sure, they can live close to 200 years, which sounds like an eternity, but down in the deep ocean, a 200-year-old is basically just finishing puberty. You see, biology on the surface is constantly punished. You have to fight gravity, you have to survive freezing winters and scorching summers, and worst of all, you're constantly bombarded by solar radiation that is just slowly chipping away at your cellular DNA. But once you strip all those things away and sink into the dark, the biological timer just kind of slows down.
Section 1. Bypassing biology. The bowhead whale.
Okay, let's dive into this. As we begin our descent into the freezing subarctic waters, we meet our first incredible survivor, an animal that absolutely should not be able to live as long as it does. Bowhead whales routinely live over 2 centuries, and the way we actually figured this out is totally wild. Scientists literally found 19th century harpoon tips still buried deep in the living blubber of these whales. They had just been swimming around for over 100 years with antique weapons stuck in them, completely unbothered. It's an incredible realization. But for a 100,000-pound mammal, living this long introduces a fatal microscopic problem.
And that problem is cancer. Cancer is essentially a numbers game. Every time a cell divides, there's a tiny chance it makes a typo in its DNA. Since a bowhead whale has thousands of times more cells than a human and lives twice as long, standard logic says they should be absolutely riddled with tumors by the time they hit 50. But they aren't. This brings us to a really fascinating biological mystery known as Peto's paradox. These massive whales bypass this fatal flaw by evolving highly advanced DNA repair mechanisms. Their genetics actively hunt down and fix damaged DNA in real time. They literally heal their own genetic code before cancer can even begin to form.
Section 2. Half a millennium slowdown. The Greenland shark.
Now, even with perfect DNA repair, if you want to push past that 2-century mark, you have to stop acting like a normal animal. We're dropping our pace now, plunging deeper into waters that are barely above freezing, to meet a creature that stretches a normal lifespan out over 500 years. Imagine surviving half a millennium by simply stopping. They have a single heartbeat every 10 to 12 seconds. A normal human heart beats, 60 to 100 times a minute? The Greenland shark has effectively dropped its metabolism to near zero. They grow at this microscopic rate of about 1 centimeter a year, and their maximum cruising speed is literally slower than a human casually walking through a grocery store. Everything is just in extreme slow motion. But here's the severe catch. There is a 500-year tax. Being a Greenland shark is honestly kind of completely miserable. For starters, they're almost all entirely blind due to a very specific parasite that literally eats their eye tissue, leaving these weird worms dangling from their useless eyes in the pitch black water. And you might be wondering, why doesn't anything just eat them while they slowly drift around? Because their flesh is heavily toxic. They shove urea, yes, that's what's in urine, and a chemical called TMAO directly into their tissues to act as antifreeze. They are essentially swimming blind biohazards.
So this brilliantly illustrates the ultimate game of survival. On one hand, you've got the great white shark, fast, aggressive, a legendary coastal predator, but with a 70-year lifespan. On the other, the Greenland shark, a blind, toxic, incredibly slow scavenger that lives for 500 years. If they fought, obviously the great white wins instantly. But the Greenland shark wins the waiting game. A single Greenland shark will completely outlive 7 entire generations of the great white shark, just by floating in the deep, freezing dark, completely unbothered by time.
Moving on to Section 3, the 10,000-year sleep, black coral, and glass sponges.
Let's see how this concept builds as we descend to the absolute bottom of the ocean. Down here in this incredibly stable, highly pressurized environment, lifespans literally stop being measured in centuries and start being measured in millennia. The scale here is awe-inspiring. Way down at the bottom of the Antarctic Ocean sits the glass sponge. Get this, an individual sponge born 15,000 years ago, before humans even invented agriculture, is still alive today. While the ancient Egyptians were dragging giant stones to build the pyramids, this sponge was just sitting there. They have no brain, no heart, no nervous system. They traded every single aspect of actually experiencing life just to filter freezing water and never, ever turn off.
But as always, this strategy comes with a fatal, heartbreaking catch. Because they've spent 15,000 years perfectly static, doing absolutely nothing to adapt, they have zero defenses. An animal that has survived the entire span of human civilization can be instantly crushed in a fraction of a second by a random piece of rope and metal from a deep-sea fishing net. Beating the aging process means absolutely nothing if you're fragile enough to be wiped out by a single physical impact.
Section 4. The Immortal Jellyfish Reset. Turritopsis dohrnii.
Up until now, the animals we've talked about have survived by basically just slowing down time. But we're about to shift gears because we are now looking at the ultimate biological rule breaker. This tiny pinky nail-sized animal doesn't just age slowly, it completely ignores the concept of aging altogether. And the craziest part, it happens through extreme stress. If this jellyfish is starving, freezing, or physically injured, it hits a biological panic button. It drops to the seafloor, literally melts down into a tiny blob of tissue, and completely rewrites its own cells through a process called transdifferentiation. A muscle cell transforms into a nerve cell, it rebuilds its entire body from scratch into a baby polyp, and just starts its life over with the exact same DNA. It literally uses getting hurt as the trigger to stay young forever.
But biology absolutely loves dark irony. If this jellyfish is biologically immortal, why isn't the ocean just overflowing with them? Well, because the reset takes days, and you cannot hit the reset button if you are actively being digested. If a passing sea turtle swallows the jellyfish whole, it's game over. So the only biologically immortal animal on the planet is basically just a defenseless, squishy piece of protein sitting at the absolute bottom of the food chain.
And finally, Section 5. The Price of Living. Why Evolution Demands Death.
This brings us to the most profound question of this entire explainer. If a tiny jellyfish can literally reset its cells and a shark can live 500 years, why didn't evolution make human beings immortal? Why are we literally designed to die? Well, the brutal truth is that if you want evolution to actually work, things have to die. Down in the static, frozen deep ocean, a 10,000-year-old sponge doesn't really need to change. But up here on the chaotic surface, the climate shifts, predators get faster, and viruses are constantly mutating. If a species never dies off to make way for new offspring, their DNA never upgrades. An immortal species on land would have an immune system thousands of years out of date. Death is the very mechanism that forces biology to adapt and survive. It is the engine of evolution itself. Extreme lifespans demand massive sacrifices. Sure, you can live for 500 years, but you must live in the freezing dark, moving in super slow motion while parasites eat your eyes. We burn through our lives in about 80 years because we are warm-blooded, complex, and fast. We consume massive amounts of energy to run high-level brains that let us truly experience the world around us. Our short lifespans are simply the evolutionary tax we pay for actually getting to do things. So I'll leave you with this. Would you trade your 80 years of vibrant, conscious life for 10,000 years sitting mindlessly in the freezing dark? Think about it. Thanks for joining me on this explainer, and I'll catch you on the next deep dive.